Hello everyone, welcome to workshop on development of project using Iot and ML. I am Chella Sumalni and would be the host for today's event. Kakatiya Institute of Technology and Science Warangal is an autonomous institute under Kakatiya University Warangal. This institute is awarded with NAC A grade ranked with 197 NF. Department of Electronics and Communication Engineering in collaboration with Indian Society for Technical Education jointly presents a virtual workshop on development of project using Iot and ML. This workshop explains about how to develop projects using machine learning and Iot. The student coordinators for this workshop are G. Arun Kumar, M. Vaibhava Praneeth, P. Samresh and C. H. Sumalini. Student coordinators are Dr. B. Vijay Kumar, Assistant Professor, Dr. T. Shental Murugan, Member Secretary, and Dr. H. Ramesh Babu, Assistant Professor, Co-Coordinator. We would like to thank Co-Convener Sri M. Narasimha Rao, Assistant Dean Student Affairs, Convener Professor G. Raghotam Reddy, Dean Student Affairs, Principal Professor K. Ashoka Reddy, Treasurer Sri P. Narayana Reddy, Chairman Captain V. Lakshmi Rantau Rao sir, for giving us this opportunity to handle the event. Once again, I welcome all of you to virtual workshop on development of project using Iot and ML. Now let us discuss about topic for today's workshop. The topics are fundamental of Iot, interfacing of sensors and actuators, wireless technologies in Iot deployments, data exchange Iot protocols, introduction to machine learning, data visualization and basic machine learning algorithms. Now first let us discuss about what is internet and what is internet of things and how they are related to each other. So basically internet is a network that transmits variety of data across interconnected devices. We use this internet in finding information, communicating with people and in online shopping or for entertainment purpose like watching videos or browsing, etc. Next, what is Iot? Iot refers to ability of devices to share data using internet. These devices are embedded with sensors, softwares and other technologies. Iot enables automatic process that saves time for humans and makes life comfortable. This concept is mainly used in artificial intelligence and Iot is used in healthcare, smart homes, traffic monitoring, agriculture and waste management. Best examples of Iot devices are laptops, mobile phones, smartwatches, coffee machines, which we use in day-to-day life to reduce the time and effort. Next we discuss about evolution of Internet of Things. In 1989, Tim Berners-Lee discovered World Wide Web, which is an information system which enables information to access over the internet. The first internet device is created by John Romke in 1993. He has invented an internet toaster which consists of an robotic crane which itself picks the slice of bread and drop it into the toaster and it can automatically turn on and off. This is done by using transmission control protocol and internet protocol networking. Next, the Internet of Things is coined by Kevin Ashton In 1999, IoT has been developed from 1989 and it has been expanding day to day. This is the definition of IoT. And now let's discuss about characteristics of IoT. There are 5 main characteristics of IoT, and first one is dynamic and self-adapting, second one is self-configuring, third one is interoperable communication protocols, fourth one is unique identity, fifth one is integrated into information network. So let us discuss them briefly. So what is dynamic and self-adapting? IoT devices has ability to adapt themselves to the environment and take actions accordingly. For example, surveillance cameras. So these cameras has ability to detect objects. So when there are object in front of the camera, they detect the object, and if there is no object in front of the camera, they run in low power mode, and in night they will shift to infrared mode so that they can see the objects clearly. And coming to self configuring, the best example of self configuring is weather monitoring system. So IoT sensors receives instructions from different sensors and follow them accordingly. So this reduces the human effort. Next is interoperable communication protocol. There are different communities and protocols, and we can there are different communities and protocols. So apart from all that, we have standardized the communities and protocols so that every user can use them accordingly and across different devices. So best example of that is transmission control protocol. And next is unique identity. Next topic is architecture reference model. It consists of two parts, reference model and reference architecture. And coming to reference model, foundation of IoT reference architecture is the reference model. It describes about IoT devices, information managed by IoT system. Reference model has number of submodels, and this is the reference model, and all the yellow arrows show how concept and aspects of one model are used as basis of another model. So in the last we have domain model, which is also known as key model. It sends the information or data to the information model, and their information is sent to the functional model, and functional model consists of communication model and security model. And these IoT domain model has 3 different type of devices called sensors, actuators and tags. Next is reference architecture. This reference architecture is starting point of architecture, and it explains the essential parts of architecture and also design principles and guidelines and entities of the architecture. It guides and serves from one system to the other. Next is logical design of IoT. Basically, this logic design explains about abstract representation of entity. It does not explain the detailed explanation for the entities. These this consists of different layers. First layer is application layer, and it has parts like management, services, communication, security and device. All the data is present in the devices, and these data can manage itself and communicate between itself and provide services, and it has security. So when we transfer data from one device to another device, inst- we sh- so when data is transferred from one device to another device, instead of hacking, we provide security, and all these functional blocks provide system the ability to identify, sense and communicate. Next one is IoT functional blocks. So all the data from different sensors, actuators and interfaces are sent to IoT nodes, and here IoT in end nodes, uh, it these end nodes never sends a spontaneous data. They wait for the request and send the response to the gateways and networks. These gateways are centralized hubs that connects IoT devices to the clouds with the help of internet.
Thank you very much and very good afternoon for all the delegates and people who are present in the meeting, and welcome you all in behalf of Kids Warangal Samshodhini 2022. And I am Samresh, and let's get into the topic, that is interfacing of sensors and actuators. First of all, what is sensor? A sensor is a transducer device that which converts physical parameter to the electrical, and and mainly the sensor is a sensing principles are physical and chemical in nature, and sensing principles are grouped according to the form of energy. These are different types of sensors are there, and they are mechanical sensor, thermal sensor, electrical sensor, magnetic sensor, radiant and chemical sensor. Mainly there are some characteristics of sensors are there, and that are four types. First one is sensitivity, second one is resolution, third one is linearity, fourth one is range. First, what is sensitivity? Sensitivity is nothing but the change in output of sensor to the input, and resolution is the smallest amount of change in the input that can be detected and indicated by the sensor. Linearity, it is a curve that plots the output amplitude versus input amplitude under the static conditions. First, what are static conditions? The static conditions means fixed or stationary conditions. And the fourth characteristic is range. It is determined by the accuracy required. Accuracy means the correct value or standard value. Types of sensors. Sensors are classified in two ways. One is active and passive sensors, and second one is analog and digital sensor. What are active sensor? It is a type of sensor. It produces the output with the help of external supply. And what is passive sensor? It is a type of sensor that produce output signal with the help of external supply. Analog sensor. Analog sensor, the sensor that produces continuous wave, that is sine wave, with respect to the time with analog output is called as analog sensor. Digital sensor is nothing but when the data is converted and transmitted digitally, it is called digital sensor. Discrete signals are non-continuous with time. It can be represented in bits for serial transmission, and for bytes in parallel transmission. The bit is a single bit that can be a whole, either 0 or 1. Whereas the byte is known as the 8 bits is equal to 1 byte. And digital input can be in form of logic 1 or logic 0, that is on or off. Logic 1 is used for on, logic 0 is used for off. Here Here we can see different types of sensors like IR sensor, LDR sensor, heartbeat sensor, ultrasonic sensor, touch sensor, etc. And here we can see different types of sensors, that are temperature sensor. It is a sensor which senses the temperature and measures the change in temperature. And mainly this sensor has four pins, that is VCC pin, output pin, no connection pin and ground pin. And VCC for this sensor is 3.3 volts to 5 volts, and supply current for this sensor is 0.3 milliamperes, and it will measure up to 0 to 50 degrees. Temperature measurement error will be plus or minus 2 degrees. And mainly the temperature sensor type is DHT11 sensor. It is used to measure the temperature and humidity, and it is of less cost. The applications of temperature sensors are it can measure both parameters, that is temperature and humidity at the same time, and it's a low cost and it is useful for the experimental purposes. Next one is infrared sensor, that is IR sensor. IR sensor are light based sensor and used in various transmitter. The image shown has two LEDs, that is white one is for transmitter and black LED is for receiver. And mainly this IR sensor is used in a daily in the real time applications, that is visit counter. Mainly the visit counter widely used in this shopping malls. And IR sensor can be used in remote controls objects like TV remotes, AC remotes we will use. Next sensor is ultrasonic sensor. IR sensor, to overcome the range issue in IR sensor, we are using ultrasonic sensor. The basic principle of ultrasonic sensor is speed is equal to distance by time. But here in this sensor, the distance will be doubled because of reflection wave with the object. And applications of this ultrasonic sensor are object movement detection. It is simply radar and it's used in distance measurement. Real time applications for this ultrasonic sensor are submarines and radars. And next sensor is accelerometer. Accelerometer is a type of sensor is used to detect the changes in position, velocity and vibration by sensing the motion. The main applications of the accelerometer are acceleration of any objects can be detected. It can be used in wearable devices like electronic gadgets like smartwatches for monitoring the step counting and activity monitoring. And the next sensor is a gyroscope sensor. It is a sensor that can sense the rotation, and accelerometer can't sense the rotation. And the main application of gyroscope sensor are it can be used in compass and automatic pilots on ships and aircrafts, and can be used in space launch vehicles, basically missiles and orbiting satellites. And it can measure the rate of rotation and helps keeping the drone balanced. It helps in drone to keep balance. Next sensor is pressure sensor. It is a device for pressure measurement of gas and liquid. It produces the analog output voltage input 3 to 5 volts DC. The pressure sensing range will be 300 to 1100 HPa, 912 nanometers, and resolution will be 0.25 meters. And the applications of pressure sensor are pressure measuring applications. Pressure can be calculated in high altitude places like hill stations and mountains. Underwater pressure can be measured by using this pressure sensor. Next sensor is motion sensor. Motion sensor is a sensor uses one or more multiple technologies to detect movement in area. The working voltage range of motion sensor is 4.5 to 20 volts DC, and detection range will be less than 140 degrees. And the sensor is also called as PAR sensor. It is used to detect the motion of any object. The applications of motion sensors are intruder alarm, like a thief alert. Whenever a unknown person enter into the house, it will sense people by using alarm. And automatic doors, whenever a person passes through this sensor, automatically the doors will be opened by using this sensor. We will use this sensor for motion detection. And next sensor is gas sensor. Gas sensor, also known as a gas detector, are the electronic device that detect and identify the different types of gases. And usually this sensor is used to detect toxic or explosive gases and measure the gas concentration. Mm. Next sensor is heartbeat sensor. Heartbeat sensor is an electronic device and it is used to measure the heart rate, that is speed of heartbeat. And also we will call this sensor as a pulse sensor. Voltage required for this sensor is 3.3 to 5 volts, and the current required for this sensor is 4 milliampere, and the sensor is used in wearable watches to monitor the heartbeat. Next sensor is pulse oximeter heart rate sensor. It is a integrated pulse oximeter and a heart rate monitor sensor solution. It will measure the observance of pulsing blood through the photo detector. Input voltage for this is 1.8 to 5.5 volts. Next sensor is pH sensor. A pH sensor helps to measure the acidity or alkalinity of water with a value of between 0 to 14. When pH value is below even, then the water is when the pH value is below 7, then the water is acidic. The input voltage for the sensor is 1.8 to 5.5 volts, and the measurement range for the sensor is 0 to 14 pH. We will measure 0 to 14 stages levels in this pH sensor. When the sensor is dipped in any medium, the pH is detected. The best application is pH level of water. If the pH is more or too less, the water is not safe to drink. So with the help of this sensor, the pH level of the water can be checked. And whenever check the water is acidic, we will won't use that water. If you use that water, it will be cause damage to our body. So better to avoid that, we will use pH sensor to check the acidity and alkalinity in water. Next sensor. The next sensor is water flow sensor. It is installed at the water source or pipes to measure the rate of flow of water and calculate the amount of water that is flowed through the pipe. And the flow of water is measured as liters per hour. It requires a voltage of 5 to 18 volts DC. Current draw is 15 milliamperes. Working flow rate of water flow sensor is 1 to 30 liters per minute. And the next sensor is rain sensor, and it is a sensor. It is used to detect the rain and rainfall intensity measurement and monitoring. We will use this sensor for measurement of rain and monitoring the rain. Whenever the rain will fall, we will check by using this rain sensor. A required voltage for this sensor is 3.5 volts to 5 volts. The output type will be analog output voltage and digital switching voltage, that is AO and DO. And the next sensor is fingerprint sensor. The fingerprint sensor is one kind of a sensor which is used in fingerprint detection device. And mainly this fingerprint consists of 6 pins, that are weighing pin, ground pin, transmitter pin, receiver pin, and we have two inputs, that is 5.5 volts and 3.3 volts. We will use the sensor line we will connect between 5.5 volts and 3.3 volts. And these devices are mainly inbuilt, and the fingerprint detection module, this is used for computer safety. And in this R305 sensor is one kind of fingerprint sensor module, which is used in biometric for security in fingerprint detection as well as in verification, like Aadhaar cards. We will use this kind of sensor, and these are different fingerprints are there. And mainly that different types of fingerprint sensors are R305 fingerprint sensor, R307 fingerprint sensor, capacitive sensor, and another one is thermosensitive fingerprint sensor. And the next sensor is sound sensor. The sound sensor is a sensor, and it is a module that detects the sound waves through the intensity. The voltage signal for sound intensity can be obtained by analog to digital conversion. And the next sensor is soil moisture sensor. The soil moisture sensor is used to measure the water content in soil, and it makes ideal for performing experiments in courses such as soil science, agriculture science, and environmental science. And the sensor works with 5.5 volts to 5 volts, 3.3 volts to 5 volts, and it will also measure the moisture content in soil. The distance between two leads will be calculated, and moisture content will be calculated.
Next we are going with actuator. First, water actuator. An actuator is a component of a machine that drives the mechanism or system. An actuator is a device that makes something move or operate. It receives a source of energy and uses it to move something. Next we will learn more about what actuators are and various types of actuators. Gear. Gear. It is a type of actuator which typically creates movement using a basic worm gear. Next one, belt drive. It will convert a rotary motion to linear motion by means of a timing belt connected between two pulleys. Next one is bearings. Bearing usually reduce the friction, and in bearing there will be a ball bearing also. And bearings are parts that assist objects rotation, and it is a type of actuator. What makes an actuator move? Actuator receives a source of energy and use it to move something and pull it another way. The actuator converts a source of energy into a physical mechanical motion. In that electrical actuation system, there are different actuation systems are there in electrical system. They are switch. A switch is an electronic component that can make or break an electrical circuit. And hand actuated switch means that the switch is operated manually using physical contact. Next one is relay. A relay is regarded as a binary actuator as it has two stable states. Relays are either energized and latched or de-energized and unlatched. The relay permits a small amount of electrical current to control high current loads. When voltage is supplied to the coil, small current passes through the coil, resulting in a larger amount of current passing through the contacts to control the electrical load. Next one is solid state relay. A solid state relay (SSR) is an electronic switching device that switches on or off when an external voltage AC or DC is applied across its control terminals. They serve the same function as electromechanical relay, but as solid state electronics contain no moving parts and have a longer operational lifetime. Next one is solenoid valve. A solenoid valve is an electrically controlled valve. The valve features a solenoid, which is an electric coil with a movable ferromagnetic core plunger in its center. In the rest position, the plunger closes off a small orifice. An electric current through the coil creates a magnetic field. The magnetic field exerts an upward force on the plunger opens the orifice. This is the basic principle that is used to open and close the solenoid valve. The solenoid valve is only used for cleaning liquids and gases. Indirect operated values requires a pressure differential to function, and these are used to close, open doors, distribute or mix the media with two or more inlets or outlets. And fast acting. Solenoid valves can get hot as its required energy to switch and stay in that position depending on type. Common in heating systems, compressed air, vacuum, irrigation, car washes, etc. Next, DC motor. A DC motor is an electrical machine that converts electrical energy into mechanical energy. In a DC motor, the input electrical energy is the direct current which is transferred into the mechanical rotation. A DC motor is defined as a class of electrical motors that converts direct direct current electrical energy into mechanical energy. From the above definition, we can conclude that electrical motor that is operated using direct current or DC is called as DC motor. Next one is servo motor. A servo motor is a type of motor that can rotate with great precision. Normally, this type of motor consists of a control circuit that provides feedback on the current position of the motor shaft. This feedback allows the servo motors to rotate with great precision. If you want to rotate an object at some specific angles or distance, then you will use servo motor. It's just made up of a simple motor which runs through a servo mechanism. The applications where electrical actuators are used. Electric actuators appear in a number of industries. Typically, they are used in electrical applications associated with manufacturing valves, pumps, and motors. They are most commonly automate industrial valves, and many types of technical processes plants use them, including upstream, midstream, and downstream oil and gas plants, wastewater treatment plants, power plants, food and beverage plants, farming and agriculture plants, pulp and paper plants. Thank you.
Oh, so now we are discussing on wireless technologies in IoT deployments. And now the what at present the basic wireless technologies in IoT, and we are going to discuss in upcoming slides. And the first one and the basic wireless technology we are using is OSI module. OSI layers or OSI modules is both are same, and OS is nothing but Open System Interconnection Model. It is a conceptual model that characterizes and standardizes the communication functions of a telecommunication computing system. And OSI, Open System Interconnection, without its regard to its underlying internal structure and technology. And its goal to interval or diverse communication system with standard communication protocols. And it has a standard communication protocol which is basically common to all the standards we are using in IoT deployments. And Open System Interconnection deals with an open system. It deals with open systems, that is systems open for communication with other systems, and specified in ISO 7498, and is consist of 7 lists. So ISO 7498 is nothing but a standardized number given for the OSI layer, OSI module. And here you can see the 7 layers, that is layer 1, layer 2 up to layer 7. Those are described in chronological order: the application layer, presentation layer, session layer, transport layer, network layer, data link layer, physical layer. And the starting 4 layers, that is 7, and application layer, presentation layer, section layer, and transport layer, relates to communication technology. And the last 3, that is network layer, data link layer, and the physical layer, relates to user layer, user application layer. So, best example of OSI module is when you communicate from one person to another person via WhatsApp or any other social media platform. You can see this layers will be activated on all the time when you communicate or contact another person. So, as an example, you can see here there are 7 layers present in OSI. Those are described in chronological order, that is layer 1 physical layer, data link layer, network layer, transport layer, section layer, presentation layer, application layer. Here you can see the up to layer 7 for one user, and it will be in the same position as for another user. Just assume as contacting from one person to another person via cell phone or any WhatsApp message. You can see that the data will be sent to the server, and server will be sent to the another user. So in what is the basic protocol, what is the basic wireless technology here is OSI layer. And we'll going to discuss brief more about this particular layer and particular section in next slides. So first of all, what is application layer? Application layer is abstraction layer that specifies the shared communication protocol and interface methods used by host in a communication network. It is present top of the OSI model. It is a starting position. It layers through which the users interact and provide service user to the user. The standard TCP/IP such as TFP and TFTP, FTP, and Telnet commands. Applications layer is nothing but the last layer in the OSI model where the user can see and interact with another person. And second, there is a layer 6 is presentation layer related to representation of transmitted data. Translates different data representation from application layer uniform standard format. Suppose assume your data is in article format, that is your the data is in, as you're calling your friend, the data will be in audio file, right? Audio file will be converted to another format so as to convert it into bits, and the bits can be transferred to another location for the retrieving of the data. And here the presentation layer acts as this position where it provides services for secure efficient data transmission. It presentation, as a name represents presentation, where the how the data is going to transfer and where the data is going, all will be present in this layer. And in this layer it will be discussed about IP address of the data and everything, where the data need to be sent and where the data need to be received. Here in the presentation layer the data will be secured, and it provides us data encryption and data comprehension of the data. Session layer allows two applications of different computers to establish and end the section. Example, file transfer, remote login. Establish dialog control regulates with the side transmits plus how long it transmits. In session layer, it establishes a secure connection between one user and another user. When you as you can see the WhatsApp, you are seeing a message that end-to-end encrypted. They are using basic OSM model where the section layer is acting there. So it provides it provides a established connection between you and your friend or anyone. It provides a secure established connection, and after your communication path is completed, it will automatically switches off the section layer, and your communication part will be completed. So section layer will acts as a medium between two users for acting to on and off. And the transport layer manages transmission package, repackages long messages when necessary into small package for transmission, and resembles a package in correct order to get original messages, handles errors recognition and every recovery. Transport layer at receiver receiving acknowledges packet delivery, resends missing package. So in transport layer, when the data is converted into a long messages, suppose a long audio file is there, and those long audio file is converted into small package for which will be good for transmission, easy for transmission. So when the data is converted from a long message to a package, the error identification will also be easy, and if there is any error rectification will also be very easy, so that the communication will be well good and well fine. And if there is any package missing, so we can know that which of the part is which part of the audio file is missing, so we can again resend, so that empty file will be completed and totally new communication path will be established. And network layer manages addressing routing data with the subnet. So network layer addresses manages translates logical addresses and names into physical address, determine the route from source to destination computer. Routing can be based on static tables determined at start of each section. Suppose assume you are texting your friend, so where the text need to go, how it is going, and how fast it is going, those are calculated in this network layer. And while receiving also, the process will be same, where the data need to be received, and how from where the data is being receiving to the end, and the all paths will be coming under this network layer. And second layer is data link layer, packages raw bits from physical layer into frames. So as the segments are converted into packets, those packets will be converted into raw bits, that is raw bits from into frames. Those frames will be converted into bits using physical layer. So now the data link layer, it waits for acknowledgement from the receiving computer, retransmits frame for acknowledgement not received. So you are sending the data, but you may not know whether the data is being received by the end user or not. So data link layer takes acknowledgement from the end user, so that the data is received or not from the end user. It just like it acts as a feedback from the end user. It acts as a feedback in between two users, whether data is transmitted or received. It takes as an acknowledgement. And in layer 1, the physical layer, it transmits bits from one computer to another computer. The frames is converted into bits, and it transmits bits from one computer to another computer. Regulates the transmission of stream of bits over physical medium. Defines how cable is attached to a network adapter or transmission technique is used to send data over the cable. And the physical layer is last layer, which we can see through a naked eye. So OSA, there is a standard open system interconnection, the standard one. So OSA versus internet protocol, what is the difference between both of them? So at left you can see all the 7 layers, that is of OSA layers, and right you can see your 5 layers, that is of internet protocol. In internet, what is being acting in the backend. So compared to OSI, starting three layers, application layers, presentation layer, section layer, are converted into a single layer, that is application layer. And transport layer, network layer. Network layer is divided in two parts, and first part with attachment to the transport layer, it will be calculated as TCP, and the network with half part of the data link layer is converted to the IP, that is internet protocol. And data link layer is the same as network interface. Physical is converted to hardware. There is no change in physical to hardware. And now we are going to discuss data exchange IoT protocols. So basically there are 4 basic communication modules, that is request response communication model, publish subscribe communication model, push pull communication model, exclusive pair communication model. Now we are going to discuss data exchange IoT protocols. As I said previously, that is a request response communication. The basic four communication modules are request response communication model, publish subscriber communication model, push pull communication module, exclusive pair communication module. So first one we are going to see is request response communication model. The request response communication model is in which the client sends a request to the server and server responds to the request. When the server receives a request, it decides how to respond and fetches the data, retrieves resource representation, prepares and responds, and then sends the response to the client. As you can see, the image represented here is a basic request response communication model. Here, assume client as a user, that is as, and the server as a in between portal, and the resource is last on a storage device. Suppose assume you are having a Chrome website. So if you I want this information about cat pics that or in dog pics, so if you send the request, the server receives the request from the client, and from the resources it collects all the dog images and it shows us as a response. So it basically as I'm telling as a basic example, as part of Chrome, as part of Chrome. And the second one is publish subscribe communication module. Publish subscribe communication module. The publish subscribe is a communication model that involves publishers, brokers, and consumers. Publishers are the source of data. Publishers send data to the topics which are managed by the broker. Publishers are not aware of consumers, and consumers subscribe to the topics which are managed by the broker. And when the broker receives a data from a topic from the publisher, it sends the data to all the subscribed consumers. Here the publisher, that is consumer, so assume consumers are we, and suppose we are the consumers, so I need some animal images. So the broker here subscribe to the publisher, so he only has animal images, so we need to subscribe to the broker, and the broker will gets the data from the publisher and sends the information to us. And it is basic, we are not using the at present we are not in a position to use this publish broker consumer part. It will taking a lengthy process that and limited resources will be present in the publisher part, so a broker need more time to get a new publisher for new data. And to overcome those problems, we are using the push pull communication module. Push pull communication module is communication module in which the data producers push the data to the queues, and the consumer pulls data from the queues. Suppose as here the image represents here is publisher, consumer 1 and consumer 2. Suppose publisher, so assume we are as previous as said, so assume we are as a consumers, so you need data from the publisher, so there is no broker in between the publisher and us. So the publisher has a data, but he will be sending those data in a queued format, that is one by one the data will be coming to the consumer, and the responses will also be coming getting in the one by one order, and the request will also be sending to the consumer in one by one order. And so the queued process is also a lengthy process, and it may take some time to gather the data from the publisher or get the data in the queued format. It may take some time to receive to the consumer. So to overcome all these communication models, the exclusive pair communication model is established, and it is a bidirectional fully duplex communication module that uses a persistent connection between client and server. Once the connection is set up, it remains open until the client sends a request to close the connection. Client and server can message to each other after connection setup. So now client and server are only present here. In between there is no broker, there is no publisher. So the server has the data, it will send the data. So the basic example, it is a Yono SBI or Google Pay. Suppose take as Google Pay, and I'll tell a basic example with Google Pay. So when you type the pin in the Google Pay, it directly opens app, and it shows the details, contacts, previous payments what we have done, electric bill payments, and the bill payments it will be showing us. So if we click on the mobile recharge, it will show us a mobile recharge. So assume that is if you are clicking a mobile recharge, it will send a response in according, and it act as a response, and it will showing the numbers which you need to register, you need to register for recharging. So it will be gesting basically a question mark and answer, question and answer. And another example, if you want to fetch an account balance on Google Pay, when you type the fetch account balance, it will automatically showing the savings account and the balance present in your account with the help of this exclusive pair communication module, and data exchange protocols. So IoT device, those previously discussed the communication modules. Now we are going to discuss data exchange protocols. IoT device use network standards and protocols to allow physical objects to interact with each other and the cloud. The protocols provide practical information for managers and frontline staff to integrate data definitions and requirements into existing administrative practices. There are many protocols available, and we have a few discussing below. And first one is what is the role of protocol in IoT. IoT protocols are a crucial part of them. IoT technology stack. Without them, hardware would be useless, as the IoT protocol enables it to exchange data in a structured and meaningful way. So there are two types of IoT protocols and standards can be broadly classified into two separate categories, such as IoT network protocol and IoT data protocol. IoT network protocol. So first we are going to discuss on IoT network protocol. IoT network protocol are used to connect devices over the network. These are set of communication protocol typically used over internet. As a network mentioned here, it will be used only for over internet. Using IoT network protocol, end-to-end data communication within the scope of network is allowed. Following are the various IoT network protocols. Those three are HTTP, LoRaWAN, and Bluetooth. HTTP is nothing but hypertext transfer protocol. LoRaWAN is nothing but a long-range wide area network, and at last third one is Bluetooth. And now we are going to discuss brief about the in upcoming slides. HTTP, that is Hypertext Transfer Protocol. Hypertext Transfer Protocol is a best example of IoT network protocol. This protocol has formed the foundation of the data communication over the web. It is the most common protocol that is used for IoT devices where there is a lot of data to be published. However, the HTTP protocol is not preferred because of its cost, battery life, energy saving, and more constraints. So, and now the server that the browsers we are using is using the HTTP protocol to send the request and to get the response from the server. HTTP is the foundation of data communication for the World Wide Web. Hypertext is structured text that uses logical links, hyperlinks between nodes containing text. HTTP is a protocol to exchange or transfer hypertext. The standards development of HTTP was coordinated by Internet Engineering Task Force (IETF) and World Wide Web Consortium (W3C), culminating in the publication of a series of requests for comments. The first definition of HTTP/1.1, the version of HTTP in common use, occurred in RFC 2068 in 1997. Although this was obsoleted by RFC 2616 in 1999. HTTP functions as a request response protocol or request response communication module in which the client server computer model are present. A web browser, for example, maybe client and application running on a computer hosting a website may be the server. So now we are going to discuss IoT data protocols. And IoT data protocols are used to connect low power IoT devices. These protocols provide point-to-point communication with the hardware at the user side without any internet connection. Connectivity in IoT data protocols is through a wide array cellular network. Some of the IoT data protocols are discussed below. Those are MQTT, COAP, AMQP, and M2M, that is the Message Queue Telemetry Protocol (MQTT), Constrained Application Protocol (COAP), Advanced Message Queuing Protocol (AMQP), and Machine-to-Machine Communication Protocol is M2M model. And we are going to discuss brief about them in a more upcoming slides. The first one is Message Queue Telemetry Transport Protocol (MQTT). One of the most preferred protocol of IoT devices, MQTT collects data from various electronic devices and supports remote device monitoring. So consider this as the main part, supports remote device monitoring, and it is a subscribe publish protocol that runs over transmission control protocol, that is internet protocol, which means it supports event driven message exchange through wireless networks. You can see the image presented at last is publisher there will be a MQTT broker, and suppose the subscribers are us. So when you take a subscription from the MQTT broker, so it automatically publishes data to the cloud. So assume publish as a cloud, and so if you subscribe to the MQTT broker, he sends the data of our information to the cloud and retrieves whenever we require the data from the cloud. So there will be a broker in between server and users. So what are features of MQTT and why we are using mostly in all the communication models we are at present we are using. So lightweight, efficient. So it is a main one. So MQTT clients are very small, requires minimal resources, so can be used on a small microcontroller. MQTT message headers are small to optimize network bandwidth. It is a very lightweight protocol. That is, we can also use in Node MCU and Wi-Fi modules. At present, we are using MQTT protocol, and in Raspberry Pi we are also using the MQTT protocol, and many other modules are also using MQTT protocol due to its lightweight and very efficient and compared to another protocols. And second point is bidirectional communication. MQTT allows messaging between device to cloud and cloud to device. This makes for easy broadcasting messages to group of things. Suppose as I said, when we want information from the cloud, and cloud also sends the information from, not only uploading but also we can retrieve the data from the cloud. So it is bidirectional communication, not in a simple duplex communication. Okay, and scale to million of things. MQTT can scale to connect millions of IoT devices. The MQTT can support that the user can connect to millions of IoT devices which they are using. And the features of MQTT: reliable message delivery. Reliable message delivery is important for many IoT cases. This is why MQTT has 3 different quality service levels: 0 at most once, 1 at least once, and exactly once. And the fifth one is support for unreliable networks. Many IoT devices connect over unreliable cellular networks. MQTT support for persistent sections reduce time to reconnect the client with a broker. Security enabled. MQTT makes it easy to encrypt messages for using TLS and authentication, and clients using modern authentication protocols such as OAuth. MQTT publish subscribe architecture. MQTT, and so it is basic example as I said previously. Suppose you have a data you have a data of temperature monitoring in your house. So when you want to upload the temperature level of the house to the cloud, so that the remotely you can monitor the data of the temperature at your home. So in between there will be a MQTT broker where the data from our site will be sent to the cloud with the help of MQTT broker. So when we want to remotely monitor the live monitoring of a temperature, then we will be using a reverse process. So the the subscriber will be sent to the data to the MQTT broker, then we will be receiving the data, live monitoring of the data. So whenever we require, the broker sends. And the second protocol we are using here is constrained application protocol. COAP is an internet utility protocol for restricted gadgets. Using this protocol, the client can send a request to a server, and server can send back the response to the client in HTTP. Here, the HTTP network protocol is used in COAP. For lightweight implementation, it makes use of user datagram protocol and reduces space usage. The protocol, so it is not using TCP. TCP is a basic internet protocol, and UDP is the user datagram protocol, which is quite different from the TCP. The protocol uses binary data format, efficient XML interchanges. COAP protocol is used mainly in automation, mobile, and microcontroller. The protocol sends a request to the application endpoints such as appliances at home, and sends back the response of services and resources in application. Here the image represented is basic COAP protocol. So application and the request responses and messages, and the in between these responses and messages, UDP, user datagram protocol, is present rather than TCP/IP protocol. That is constrained application protocol supports 4 different message types, that is confirmable, non-confirmable, acknowledgement, and reset. These are the basic messages which the COAP can support, that is whether data is transmitted or not, If they transmitted, then what is okay, it confirmed the data is transmitted. If it's not transformed, then it is not transferred, and we will get the acknowledgement from the client or otherwise the subscriber, and the reset. So normally we need to start again from the new, then we can use this future message type, that is reset. COAP versus MQTT. Why we are using MQTT rather than COAP? An important aspect to cover the main difference between COAP and MQTT. As you may know, MQTT is another protocol widely used in IoT. There are several differences between these two protocols. The first aspect is to notice the different paradigm used. MQTT uses a publish subscriber while COAP uses a request response paradigm. MQTT uses a central broker to dispatch messages coming from the publisher to clients. COAP is essentially one-to-one protocol, very similar to HTTP protocol, which is time-consuming protocol. Moreover, MQTT is an event-oriented protocol, while COAP is more suitable for straight transfer. The basic image represented here is MQTT versus and COAP. Here you can see the different clients connect to single broker, so that the data transfer and the broker will also be, there will be less brokers, and the data consumption from the broker will also very less. So and there will be one broker common for all clients, then the storage saving will also be possible in MQTT. But coming to COAP, for one client there will be one server established between, so another before once the communication path is established between client and server, until it ends, the client and server are busy, so another client cannot access the server till the previous client closes the server. And now we are going to discuss IoT gateways. An IoT gateway is a solution for enabling IoT communication. Usually, the device-to-device communication or device-to-cloud communication is possible using IoT gateways. The gateway is typically a hardware device housing application software that performs essential tasks. An IoT gateway is a fundamental component of an edge computing architecture. Its primary function is to centralize IoT devices data at an edge level, filter it, deciding what information is essential, enabling visualization and perform complex analysis. What function does an IoT gateway perform? So basically, what is a gateway? IoT gateways have evolved to perform many tasks, for simple data filtering to enabling visualization and complex analytics. So not only transferring the data from devices to cloud, the IoT gateway also performs data filtering, enabling visualization, and complex analytics also can be performed with the help of the current wave of IoT expansion. And here you can see the gateway acts as a bridge in between cloud and the user, that is IoT devices and the cloud. There will be a gateway called that, there will be in between those two parts, that is called gateway. So what is gateway? What are features of gateway set? Okay, a versatile IoT gateway may perform any of the following: facilitating communication with legacy or non-internet connected devices, data buffering, streaming, data preprocessing, cleansing, filtering, and optimization, some data aggregation, device-to-device communication, network future, hosting live data, data visualization, basic data analytics via IoT gateway application, short-term data history features, security, device configuration management, system diagnostics. Deployments of IoT. Here you can see all three deployments are compared here: IoT plus edge, IoT plus cloud, and fog. So, and now we are going to discuss brief about them. So what is basically fog computing? Fog computing is fogging or fogging. These both terms are equal, which was termed by Cisco. The idea of the fog computing extend the cloud near to the IoT device. The primary aim is to solve problems faced by the cloud computing during IoT processing and immediate layers between cloud and devices. So the image represent here is fog computing. Suppose assume in city there are n number of CC cameras present. So for the data from CC camera to the cloud, or from the CC camera to the monitor where there is a police station, so we need to monitor the CC cameras from the remote areas. So we cannot establish a wide connection from this from that CC camera to the monitoring station. So for that one, a group of CC cameras from that area will be connected to the nearby gateway, and through the gateway, that is called fog term, and the fog will be connected to the cloud, so that the for in rather than connecting a single CC camera to a same one single fog, it can be connected to the different fogs at the same time. So which fog is near to the, so which node is near to the CC camera, it connects automatically to that node, and with the help of that node the data is transferred to the cloud. And the ability of current cloud model is insufficient to handle requirements of IoT. So why we are going for fog computing? First of all, volume. So what is volume? So day by day the population also increasing, the data which the user also using, the data which is being used is also increasing. So as a research journal published, it is saying that for 1 minute a user can generate up to data of 12 GB per second. And so in order to store those huge amount of data, it is not possible in the cloud, and for transferring those huge amount of data is also not possible to the cloud. So these issues are being coined by Cisco, and this method, this type of fog computing is being established. And the second one is IoT edge computing. IoT edge computing is a distributed computing concept that integrates intelligent to edge devices, also called edge nodes, allowing data to be processed and analyzed in real time near the data collection source. In edge computing, data does not need to be uploaded directly to the cloud or to a centralized data processing system. As I said previously, here IoT edge computing. So in between the cloud and the user, there will be edge node, and so the device nearby consider again CC cameras. The CC cameras nearby connected to the edge, and with the help of the edge node, the data is transferred to the cloud. So why use of edge computing? Most companies store, manage and analyze data on a centralized storage, typically in a public cloud or private cloud environment. However, traditional infrastructure and cloud computing are no longer able to meet requirements for many real-time applications. For example, in the case of IoT, Internet of Things, and IoE, Internet of Everything, a highly available network with a minimal latency is required to process large amount of data in real time, which is not possible on a traditional IT infrastructure. In this case, the advantage of edge computing becomes more obvious. The difference between edge computing and cloud computing. The main difference between edge computing and cloud computing is where the data is being processed in the cloud computing, data is collected, processed and analyzed at a centralized location. On the other hand, edge computing is based on distributed computing environment in which data is collected, processed and analyzed locally. There is no need to choose between cloud computing and edge computing for the cloud solution. They don't compete with each other. They just complement each other and work together to provide better performance on applications. Here is a basic diagram representation between edge computing and fog computing. Edge computing is connecting two servers together, and fog computing connects those two servers and then connects to the cloud. And we have completed the different protocols and different cloud computing technologies. Now we are going to discuss applications of IoT. Applications of IoT. Here the image described here is different applications where IoT is established, that is home, cities, environment, energy, retail, logistics, agriculture, industry, health and lifestyle. We are going to describe brief in now upcoming slides. First for home automation. The main IoT is being used in home automation. So as we are going forward to the future, that is 5G technologies, the more the IoT is being established in our home. For our comforts, we are using IoT. Here you can see the image which represents different IoT technologies used. First you can see the motion sensor. So whenever there is a motion detector, so when the human passing from in front of sensor, automatically opens the door. And the environment monitoring, what is the environment present in the room, how much temperature, how much humidity is present in the room. It will monitor the environment. And door control, automatic door control, remote control. So with the help of, this is the main remote, with the help of remote control you can control TV, fan, lights and anything, AC, anything with the help of using one remote. And Security alarm. If there is an intruder enters into the house, it automatically alerts the user. And window control automatically controls the window. And light control or switches on of the light with many colors, RGB. And temperature monitoring also present in home automation. A smart lighting system, smart applications, intrusion detection, smoke gas detectors. It is meant smoke and gas detectors. When you're away from the home, or when there is any gas leakage in the home, we may not know that there is a gas leakage. But with the help of the IoT sensors present, we can detect the gas leakage in our home. So with the help of a sensors described previously, MQ4 and MQ3 sensors, we can detect carbon monoxide, liquid petroleum gas. If there's a leakage, it automatically alerts the user that there is a gas leakage in the house. At smart cities, smart cities is upcoming future cities, that is green cities, smart environment, smart water, smart street light, city surveillance, intelligent transport, traffic management, smart parking, and smart electric. Smart parking detects the number of empty parking slots, sends the information over the internet accessed by the smartphones. Smart roads provides information on driving conditions, traffic conditions, accidents, alert of poor driving conditions. So if there is any driver which he is driving very rude, driving in very rude, here the smart with the help of smart road, this driver is acting weird, and it alerts the other users who are on the road. And structural health monitoring, and monitor vibration levels in the structures, where if the building is old and the structure is going to collapse in next few months, it detects whether the cracks are forming in the building or not, with the advanced warning of imminent failure of the structure. Surveillance using large number of distributed internet connected video surveillance cameras, aggregate the video in cloud-based scalable storage solutions. Emergency response used for critical infrastructure monitoring, detect adverse effects. Smart environment, weather monitoring, air pollution monitoring, noise pollution monitoring, river flood detection, and forest fire detection. Weather monitoring collects data from several sensors and sends the data to the cloud-based application and storage backends. And air pollution monitoring monitor emissions of harmful gases CO2, NO2, that is nitrogen oxide, and etc. Factories and automobiles use gaseous and meteorological sensors integrate with the single chip microcontroller. Several air pollution sensors, GPS modem and GPS module are used for transferring data. Noise pollution monitoring use a number of noise monitoring stations, generate noise maps for data collected. Forest fire detection use a number of monitoring nodes deployed at different locations in a forest. Use temperature, humidity, light levels, etc. Provide early warning of potential forest fire. Estimate the scale and intensity. River flood detection monitoring the water level and flow rate. Rise alerts when rapid increase in water level and flow rate is detected. Smart energy system and smart grid. Smart color data regarding electricity, generate consumption, storage, conversion of energy into another forms, distribution, equipment, health data, control the consumption of electricity, remotely switches off the supply. Renewable energy systems measure the electrical variables, how much power is fed into the grid. Prognostics, that is predict performance of machines and energy system by collect and analyze the data from sensors. Smart retail, and this is just nothing but a smart shopping mall. Store layout optimization, smart shelves, beacons, robots, automated checkout. So there is no need of human intervention while shopping. So you can directly come into shopping mall and take out the do shopping and get out easily without any hassles. And in inventory management, monitor the inventory by RFID readers, tracking the products, how the product is expired, how many products are available. So when the new product is coming, it will be intimating before. And smart payments using NFC, customers to show the credit card information in the NFC enabled. Smart vending machine allows remote monitoring of inventory levels, elastic pricing of products, contactless payment using NFC. Send the data to the cloud for predictive maintenance, the information of the inventory levels, the information of the nearest mission in case a product goes out of stock in a mission. And the main is logistics. Here the IoT is acting a most prior role in logistics. So when there is a truck carrying the different goods from one place to another place for traveling a long distance, then here helps in goods tracking, helps in cargo management, enhances fuel level efficiency, enables geolocation, controls vehicle speed, engine diagnosis. For traveling a long distance, the engine diagnosis is the main. And routing, generating and scheduling generate end-to-end routes using combination of route patterns, provide route generation queries, can be scaled up to serve a large transportation network. Fleet tracking, tracking the location of vehicle in real time, generate alerts for deviation in planned routes. Shipment monitoring, monitoring the conditions inside the containers using sensors, temperature, pressure and humidity, detecting the food spoilage in the container. Remote vehicle diagnostics, detect the faults in the vehicle, warn of impending faults. IoT collects data on vehicle speed, engine, RPM, coolant, temperature. Generates alerts and suggested remedial actions. Agriculture. Future farms are small and smart. Surveying drones. Fleet of agribots are acting in between the farm. Though there will be no need of any human intervention for monitoring the field every day. So agribots will present in the field, so they'll be monitoring the field automatically. Smart tractors, remote control tractors are there, and farming data, texting cows. Agriculture, smart irrigation, use sensors to determine the amount of moisture in the soil, release the flow of water. Using predefined moisture levels, water scheduling, greenhouse control, automatically control the climatological condition inside a greenhouse using the several sensors to monitor. Using actuation devices to control valves of releasing water and switches for controlling fans, maintenance of agriculture production. Industrial IoT. So how the IoT is being implemented in industry level? So mission diagnosis, indoor air quality monitoring, sensors in machine monitoring the operating conditions, for example temperature and vibration level, collecting and analyzing massive scale mission sensor data for reliability, analyzing and fault prediction in missions. Indoor air quality monitoring. So when there are many chemical manufacturing industries present, as India is a main pharmaceutical hub of the world, so there are various pharmaceutical industries present in India. So in order to sense the various monitor harmful and toxic gases, IoT is being established there and measure the environment parameters to determine the indoor air quality, temperature, humidity, gases, pollutants, and aerosol.
Introduction to machine learning. So what is machine learning? Machine learning, we can say machine learning as a field of computer science which help the computer systems to extract the data and sense the data as we humans can sense. In simple words, machine learning is a type of artificial intelligence that extracts the patterns and it sends the data by using algorithms and methods. By using this algorithm and methods, the main aim of the machine learning is to predict the data and to predict the outcomes of the data by using previous experiences. So need for machine learning. Today, in many companies, like the famous companies like Facebook, Ola, Google and Uber, these main companies are using machine learning as their core part. And machine learning has become more significant from past 2 to 3 years. And the machine learning is the main competitive differentiator between the companies. So as there are challenges in machine learning, the main challenge is quality of data. As we get the abundance of data in real life, if we train the data, the quality of the data may reduce. And as said, the more data will come, it will take some more time to train this data. And this machine learning has emerged before 4 to 5 years. So there are no specialist persons for this and there are no experts. And we can say that there is no exactly one particular formula for exact one question. There are many algorithms. We cannot say directly one formula
cannot apply for any solution, and we are getting now overfitting and underfitting. So as we get real-time data, some data may overfit and some data may underfit, and the main is difficulty to deployment. We cannot deployment the exact method in our daily apps, and we use Python for this machine learning. Python as an interpreter high level general language, and this Python we use many, this is an object oriented approach. It will help the programmers to write clear and logical code. So Python we include Python. So we use Python as the main tool for machine learning. Python is an interpreted and high level general purpose programming language, and it's a language of object oriented approach to help the programmers to write clear and logical program for small and large scales. So Python, and this Python will allow multiple type programming paradigms. We use functional programming paradigm and procedural programmable paradigm, and mainly object oriented program paradigm. So first, the Guido van Rossum began working on Python from 1980s. So the first version of Python is released in 1991 as Python 0.9.0, but the Python 2.4 was released in 2000. And the features of Python. Python is simply and easy to learn. It is a high level language it can be understood by any human being, and it is an open source to all. Python is, as I said, it will obey procedure oriented programming and object oriented programming, and it is portable. We can use any computer for this Python, and it is platform independent. We use Jupyter Notebook for this machine learning. Jupyter Notebook can illustrate the analysis of machine learning step by step by arranging code, imaging, outputs, text, etc. in a simple manner and in a particular manner. It helps a data analyst or data scientist to go through the analysis part, and one can also take the capture of result from this notebook, Jupyter Notebook, and with the help of these Jupyter Notebooks we can share our work with the peers. So installation of Jupyter Notebook. So first we have to go to Google and we have to type in search bar Anaconda, and then we can see the Anaconda individual edition. And after downloading this Anaconda navigator in your computer, then we can see Jupyter Notebook. So here we can see the blue color box launch pad on the below of Jupyter Notebook. We have to press that, and we will get the Jupyter Notebook will be open in our Google Chrome or any other web browser. There we can see the folders, whatever the folders in our desktop will be, we can be visible in this Jupyter Notebook. So for making a new notebook, we have to go to the right side of our screen. There we can see the pop-up called new. We will get a drop down box on new. So there we have to use, and we have to check whether we want a Python 3 notebook, or we want to upload, we want a new text file or a new folder or a new terminal. So I want new notebook. So I have pressed on Python 3. So we get a window like this where we have to run the code, and the code will, and the advantage of Jupyter Notebook is we will have the categories. Say we have some blocks, so where we can get analyzed at the same time, and the NumPy library. So NumPy basically stands as numerical Python. It consists of multi-dimensional arrays. We can also perform many mathematical operations using this NumPy, and the main aim this for NumPy is to get calculated easily. we can calculate Fourier transform, and we can also calculate the linear algebra with using of this NumPy. I can say that NumPy is a replacement of MATLAB because NumPy is mostly along with SciPy in MATLAB. And coming to pandas, it is another useful library in Python and one of the favorite languages for data scientists and data analysts because Python is basically using for data manipulation, data frames. So it was developed by Wes McKinney in 2008. With the help of pandas, we can accomplish the following 5 things: load, prepare, and manipulate. For examples of Python and NumPy, we can follow the given example. So the code for this: import pandas as PD and import NumPy as NP. And here we taken the example of kitsw, kitsw, and we have assigned this np dot array is syntax for NumPy, and we have to type that on our Jupyter notebook. So data is equals to np dot array, and we have given a list here kitsw, and the next step s is equals to pd dot series data. So here this step, the pandas will make the above list KTSW kitsw in a following list. So in the following series, that will the pandas will make the following list into series. So we can see that the output will come KITSW in a series object. So types of machine learning. So different types of machine learning methods. We have 4 types of machine learning methods here. One is supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So first we go to supervised learning. Supervised learning algorithms are most commonly used in machine learning algorithms. This method take the sim- they take the data sample and it will paint. Supervised learning. Supervised learning algorithms are the mostly commonly used algorithms in machine learning. So this method learning algorithm takes the data for training, and the main objective of the supervised learning is to learn the relationship between the input data samples and their corresponding data samples, the corresponding outputs, after performing multiple data instances. So examples of these supervised learning algorithms includes decision tree, random forest, and logistic regression, KNN, etc. So based on this machine learning tasks, supervised algorithms can be divided further into 2 types. One is classification and another one is regression. So classification versus regression. So the main difference between regression and classification algorithms are: regression algorithms are used to predict the continuous values such as salary, age, price, which is continuous data, and the classification algorithms are used to predict the discrete values such as male or female or true or false, so which have only 2 phases, so it which has count which only count here. So classification is a process of finding function which helps in dividing the dataset into classes based on different parameters. So in classification, a computer program is trained on a training dataset. Based on the training, it categorizes the data into different classes. So as machine learning algorithms classification, if we go to that, we have logistic regression and support vector machines, k nearest neighbors, decision tree classification, and random forest classification. So if we go to regression, so regression is a process of finding the correlation between dependent and independent variables. So it will helpful, as we said, it will helpful in the continuous variables, prediction of continuous variables. So unsupervised learning. Here, unsupervised learning. Unsupervised learning is the training of machine using information that is neither classified or not labeled. And this here we can see that we have such dogs. So these dogs cannot have we don't have any features of these dogs here. So this type of data we have if we train and if we use this learning, this is known as unsupervised machine learning, unsupervised learning. Unsupervised learning is the training of machine using information that is neither classified or nor labeled. Here the task of computer is to group this unsorted data according to their similarities and patterns and differences. We have to categorize this data with the help of the similarities and patterns without any prior training for the data. Suppose in a given example, we have dogs. So thus the computer has no idea about the features of dogs. So we have to categorize these dogs and cats. For this, the first may contain all pics of dogs in them and the second part contain all pics of cats. So further, if we want to class, we have two categories in this unsupervised learning. These are clustering and association. Clustering, a clustering problem is where you want to discover the inherent groupings in the data. An association rule learning problem is where you want to discover rules that describe large portions of your data, such as people that buy X also tend to buy Y. So this type of data is association. So clustering methods are one of the most useful unsupervised machine learning methods. These algorithms used to find the similarity as well as the relation between the patterns and data samples. So here we can see in the given image the points are in different way. So this clustering has show the data in different types. So the clustering, dimensionality reduction. This unsupervised machine learning method is used to reduce the number of feature variables. This problem generally refers to curse of dimensionality, principal component analysis, and k nearest neighbors and descriptive analysis. Semi-supervised learning. Such kind of algorithms or methods are neither fully supervised and nor fully unsupervised algorithms used as semi-supervised algorithms. These kind of algorithms generally use small supervised learning component, that is small amount of pre-labeled unnoted data, and large unsupervised learning components, that is lots of unlabeled data for training. So in this semi-supervised data, we have data such as it has some categories, it has some labels, but the most of the data is unsupervised data. And next coming to reinforcement learning. It is an upcoming machine learning method. Here there would be an agent that we want to train over a period of time so that it can interact with a specific environment. The agent will follow a set of rules and strategies for interacting with the environments, and it will take the actions regarding of the current state of any environment. So next we are going to data visualization. So data visualization techniques can be furtherly divided into two parts: unvariate plots, multivariate plots. Univariate plots are like such as histogram, density plots, box plots. So it will give the relation between what exactly between two parameters. Multivariate plots, if you want to use maximum number of labels, and if you want to plot the maximum number of outputs, then we use multivariate plots such as correlation matrix plots and univariate plots, understanding attributes independently. So first we have known histograms. Histograms group the data in the form of bins, and it is the fastest way to get idea of a distribution of each attribute. So histogram will help you with the data scientists how the data is distributed in each data set. And density plots, it is another quick and easy technique for getting each attribute distribution in density plots. It is also similar to histograms, but it has a smooth curve to the top of tip. Box and whisker plots. Box and whisker plots, also called are box plots in short. It is another useful technique to review the distribution. In this box plots, we can see how the distribution is going on each attribute. In the block spot, we have the in box we have 75% line, 50% distribution, and 25% distribution, and outliers. So multivariate plots. So we have correlation matrix plot. Correlation is an indication about the changes between two variables. We can plot correlation matrix show which variable is having high or low. So scatter matrix plot. Scatter plots show how much one variable is affected by another variable. So it shows the relation between them with the help of dots in two dimensions way. Scatter plots are very much like line graphs in the concept that are used horizontal and vertical axis to plot the data points. So basic machine learning algorithms. And introduction to linear regression. As we said, regression is used to predict the future outcomes which by using the training of previous experiences. So for we have used the linear regression here. Linear relationship between the variables. A simple linear regression is to estimate the relationship between two quantitative variables. You can also use this regression, simple linear regression, whether we want to know about the how strong the relationship between two variables, and to know the value of a dependent variable, the certain value of independent variables. And the mathematical relationship between this for linear regression is y is equals to mx plus b. Here the y is the dependent variable where we try to predict, x is the dependent variable where we using the make predictions, m is slope of the regression, b is a constant, and m is the slope of regression line which represents the effect of x on y. Here the m represents the how the x is affecting on y, how a independent variables affects on a dependent variable. So we have both positive linear relationship and negative linear relationship. So this is a basic example predicting the speed of a car by using linear regression. So first we have to use the from sci-fi. So in a Python code we have to write from sci-fi. It is a library, import stats. So stats, here the stats is not a statistical regression, simple linear regression, whether we want to know about the how strong the relationship between two variables, and to know the value of a dependent variable, the certain value of independent variables. And the mathematical relationship between this for linear regression is y is equals to mx plus b. Here the y is the dependent variable where we try to predict, x is the dependent variable where we using the make predictions, m is slope of the regression, b is a constant, and m is the slope of regression line which represents the effect of x on y. Here the m represents the how the x is affecting on y, how a independent variables affects on a dependent variable. So we have both positive linear relationship and negative linear relationship. So this is a basic example predicting the speed of a car by using linear regression. So first we have to use the from sci-fi. So in a Python code we have to write from sci-fi. It is a library, import stats. So stats, here the stats is not a statistical function. So here we are using x is equals to, we have to give such an input data, y is equals to certain data, and we have to declare the slope, intercept, and R and study error, and here the stats linear regression x comma y. So first here I am defining my function x, and I am returning that function slope into x plus intercept. As we have here mx y is equals to mx plus b, here I am returning slope into x, mx plus intercept, that is b, mx plus b. So I am using speed my function 10. So we want to know how the function, how the output will be by using of this 10, and we are printing it. The predicted speed of car of 10 years old is this. As we show in the graph, the output will come. Logistic regression. So here we have a small example of a linear regression. We are predicting the speed of a car by from the how the car is old. So x is the value of how the car is, the age of the car, how many years has the car has from bought. Y is the speed of the, that's average speed of the car. And here we are declaring here we are declaring a linear regression for these cars, and I am getting an output for 10. So here the 10 is the age of car. So I have bought a car 10 years ago. So what is the average speed of that car? So for that we are using the linear regression, and the predicted speed of car according to the previous given data set is 85.6. Coming to logistic regression. Logistic regression is basically a supervised classification algorithm In a classification problem, the target y, the target variable or our output y, can take only the discrete values of the given set of y x values. So, in a classification problem, y will be only take only discrete values of the given x's. So, in a normal way, you can use as 1 and 0. So, types of logistic regressions. So, based on those number of categories, logistic regression can be furtherly divided into three types: binary, multinomial, ordinal. Binary logistical regression model. The simplest form of logistic regression is binary. So, in this logistic regression becomes a classification technique only when a decision has to make. So here, in this binomial logistic regression, the the output will be in a 1 or 0. So from the given data set x, the y will be in, if we train the x data input, and the prediction of the y should be the whether the category should be in 1 or 0. So it will classify the output according to the given inputs. Multinomial logistic regression. So multinomial logistic regression is similar to logistic regression, but the major difference is the output variable, the target variable may have more than one. So we can use 2, 3 also here. For an example, if you want to which if you want to know which flavor of ice cream is will a person choose. So I am taking based on ice cream. So our dependent variable is the flavor of ice cream, like chocolate, vanilla, blackcurrant, butterscotch, etc. And our independent variable is gender. So here we want to know which flavor will mostly choose it based on this independent variables like gender, age, occasion, and etc. So this is the best example for multinomial logistic regression. And here we can have a multinomial logistic regression example. Here we have a logistic regression example, whether a tumor is cancerous based on size. So our x values is the size of tumor. So we are giving size of tumor, and based on the tumor size, we have to know whether it is a cancerous or not. So for that, the given code is there. That is an example for logistic regression. Thank you.
Thank you guys for attending this workshop. Development of project using IoT and ML. The participant certificates will be provided to all the participants who are registered and attended the YouTube live. And in the comment section, you can see the Google Form link. Just fill the Google Form link. It is a quiz based assessment. So based on the merit you get, the merit certificate will be provided. And the link will be also provided in the comment section. In the pinned comment, you can see the Google Form link. Just fill the based on the merit certificate.